Okay, it's 5 p.m. now. We'll start now. Hi, everyone. A big welcome to Algothon 2023, proudly brought to you by SIG and UNSW Fintech Society. If you want to flex your coding skills, learn more about algorithmic trading, or get some hands-on experiences, you're definitely in the right event. So make sure you have secured your spot before the registration closes. We assure you it's going to be both challenging and rewarding, and you'll be having a ton of fun too. So today is workshop 1. We'll be covering programming basics. SIG will host a more advanced workshop event on the 18th of July, which is a perfect follow-up of today's session. So make sure you mark your calendars for that. If you're new to coding, today's intro session will be a great place to start. And for those who have coded before, this workshop then helps you to dust off your skills and reacquaint yourself with the essentials. Yep, actually, before we jump in, let's take care of some housekeeping. Please ensure you're on mute and scan the QR code to do the attendance form. Next slide, please. I'll pause here for a minute or two for everyone to do so. Also, we'll be having a Q&A section in the end, so please save your questions to the end and we'll be answering them as well.
Also, just for your information, this session will be recorded and posted once the event concludes on our Facebook page.
Okay, I'll start the workshop now. On to today's agenda, we will be covering from the basics to data structures, file handling, and graph plotting. We will also be introducing some super handy libraries like Pandas and Numpy. So we've got quite a bit to cover today. Buckle up and let's get started. All right, let's kick things off with a simple question. Why Python? What's all the buzz about it? In my opinion, the standard characteristic of Python is its user-friendliness. It has a clean and intuitive syntax, which emphasizes readability. This means that you are not wasting your time puzzling over the code by investing that time to make it work efficiently. What's more, Python is a big fan of reusability. It's equipped with a streamlined system of modules, packages, or external libraries, all of which can be effortlessly integrated into your code. This is extremely beneficial for more complex applications such as developing trading solutions and modeling, which is what we are all here for. But before we dive into writing the code, you need the right gear here. And what I mean by that is a suitable coding environment. There's a bunch of softwares to choose from. We've got PyCharm, VS Code, Jupyter Notebook, and the list goes on. You can basically pick whatever you feel like, what you're comfortable with. If you click on the hyperlink below the icons, you will be redirected to their website for installation guides, and it's quite easy to follow along. So I'll spare your details here. Without further ado, let's jump into our first line of code. Python is like an obedient worker. It reads your instructions from top to bottom, carrying out each one in turn. Take the print function as an example here. Once Python sees it, it prepares to output whatever is within the parentheses in the console. So if you tell it print hello August 2023, Python will promptly respond with, "Hi sir, here's our output here. Hello August 2023. Just a quick note here. If you need to leave a note to yourself or your teammate who will be editing the code later on, that's where comments come in. These are lines that Python ignores, denoted by the hashtag. So in here, Python sees the first line, hashtag August 2023, and it knows it's not an instruction. So it just skips over and executes a real print statement in the second line. So basically think of them as your sticky notes. Do you still remember learning about variables in your math classes? We also have them in Python. But here, a variable is not just limited to numbers. Next slide, please. It's more like a versatile storage box where you can put all sorts of things together. It can be strings, lists, or Boolean values. The moment you assign it a value, and your variable is born. I'll do a quick demo here. I'll do the print example here. Message is hello, August 2023, and let's print it. Print message. I'll hit the right button. So now you see Python isn't just going to spit out the word message when you ask it to print. It's a lot more smarter than that. It looks at what value you've assigned to it, and that's what it prints. Also, Python is case sensitive. So message was message message with a capital M is different with the message. So in here, Python wouldn't recognize what we are asking it to print. I also want to quickly address variable types here. There's quite a few, but the ones we'll be mainly encountering are mostly strings, integers, and floats. Strings are just text, and float are just numbers with decimal places. And I'll be using the type function here, which simply tells you what kind of variable is stored here. Print type message, type X, print type Y. Yeah, so message is a string, X is an integer, and pi is a float. Let's go back to the slides and move on to conditionals and loops. Conditionals is like asking a true or false question to Python. They allow you to make decisions based on certain conditions. So one thing to remember when working with conditionals is to indent properly. Think of it as a way of organizing your code so Python knows what falls under a certain condition. All code lines that belongs to a conditional statement need to be indented under that statement. If you forgot to do so, you'll either get an error message or Python will not recognize the code as part of that statement. So definitely keep an eye on this. In this example here, the if keywords checks if stock price is less than 10. Last slide, please. Yeah, checks if the stock price is less than 10. If this is true, Python will print buy the stock. If this statement is not true, it then moves on to the next if statement, which is short for else if. This checks if the stock price is between 10 and 20. If that's the case, then we execute hold the stock. And finally, if neither of those statements are met, Python hits an else statement and prints sell the stock. Cool. I hope everyone is still following along so far. And let's move on to loops. Loops in Python lets you run a block of code over and over again until a certain condition is met. We will talk about two types of loop here, for and while. So let's start with the while loop. The loop is saying, well, the condition is true, just keep repeating. I'll do a quick demo here. N equals to 1, well, n is smaller and equal to 5. Let's print n. And I want to increment n by 1. So in our example, Python keeps printing the value n and adding 1 to it, as long as n is less than or equal to 5 is true. So the output is just numbers 1 to 5. Please make sure that your loop's condition eventually becomes false. If not, you'll end up with an infinite loop. So here, if I delete the line n at n by 1, what happens is that the condition will be true forever, and we'll just keep executing 1, which is what we don't want to happen. So let's move on to for loops. Honestly, these are pretty similar to while loops, but they're a bit easier to understand. We often use for loops when you want to go through a collection of atoms, like a list or a range of numbers. I'll do an example here. For I in range 5, print I. Yeah, let's run it. So in our example, the range function gives us a sequence of numbers. The for loop then goes through each number, assigning it to I, and then printing it. So the output here is number 0 to 4. Let's go back to our slides and talk about functions. Functions are like your own custom commands. You can define what functions does, and then you can reuse it anywhere and anytime in your code. I'll do another quick demo here. We define a function using the def keyword, followed by the name we want to give our function. So let's define it as greet, and let's ask it to print hello Algothon 2023, and let's call it here. So that's how function works. We can also modify our functions by adding parameters within the parentheses. So it allows us to pass specific values into the functions and alter its behavior. So let's modify our greet function to accept name as a parameter. Hello name. And let's greet Alice this time. So in this example, grid is a function that accepts one parameter, which we've named name. When we call grid Alice, Python executes a function with Alice as a name. So it prints hello Alice. Also, function can return a value after execution. This is called returning. And we implement it using the return keyword. So let's create a function that adds two numbers and then returns the sum. Let's define it and call it sum, takes in number 1 and number 2, and returns their sum. And let's print it. And let's add 1 and 2 together. Yeah, and let's print it. So the print function now calls the function sum with argument 1 and 2. These values are passed into the function, added together, and then the result is returned. Yeah, so now we have covered the basics, variables, conditionals, loops, and functions. And I'll now hand over to Janice. She will get you through data structures. Over to you, Janice.
Thank you, Rita. Now I'm going to present the 4 most basic data structures in Python via a demo to keep you guys awake. And these data structures are lists, sets, and dictionaries. If you spot mistakes during the demo, please feel free to let myself or the FinTech team know. Let me share my screen.
Yes.
Cool. And let's start with lists. They are basically ordered collection of items and they can be nested, which means that the list itself can contain any type of object, including another sublist inside the list. The special thing about lists is that they are also mutable, meaning that they can be altered after being created. Here's a small exercise involving lists to actually discover a few useful functions. We can explore a list to store the weekly tutorial attendance for the term by first creating a list, which I named attendees, with each element representing each week's tutorial attendance. And so, yeah, call it attendance. But then you realize there's actually no classes in week 6 where the attendance should be 0, but it's not 0. So we can use the function, this function, attendance square bracket the index number equals to 0 to change the index number 5 equals to 0. The index number is 5 because the index number count always starts from 0. So yeah. Next, we can say that whoops, week 11 is actually a revision week without any tutorials. We can remove the last element in the list with the list name using attendance pop bracket. What if we have an emergency tutorial for the late assignment and we want to add another element at the final list, at the final position of the list? So we use attendance.append and then the element value, which I give it 20. Okay, we are done. The last step is to actually print the list for each week. In this case, we are going to integrate a for loop in here since there are multiple weeks to loop through the weeks. Yeah, as you can see the results here, it shows the number of attendance each week as well as the week number down here. Okay, secondly, let's move on to sets. They are unique collections of unique elements that do not follow a specific order. Coders like to use them when collection of objects is more important than the number of number of times it appears, or even the order of objects. Furthermore, they are mutable and useful in terms of finding overlapping elements in 2 or more steps. Here's another example. I'll remove the ones for lists first. The storyline is that we've got a list of students attending today's workshop, but some names were duplicated. Maybe it's because they signed up too many times by accident, but we are only interested in the people who signed up, not how many. In this case, let's create a list of registrations with random names and as well as duplicated ones. here. We then assume that nobody has the same name in this list, so we may use a for loop to filter unrepeated names into the set named attendees. Yeah. Finally, we can print the set out, which is basically print attendees, which Rita has covered. Complete sets of attendees have been printed without any duplications. Lastly, there are dictionaries, which are an ordered collection of items. What makes dictionaries unique is that they make use of two elements, which is a pair of elements, namely a key and a value. Once a dictionary is created, you may add, remove, or update elements using the dictionary methods. Final demo session for me. Let's use the list of attendees we have previously keep a score tally. So let me remove this and move on to dictionaries. As every name, which is a key, should have a score, which is a value, let's pretend that some people got scores. So I'll create a list first, and then add in the scores. I'll print the scores. And I'll run this. It shows each member and how many points or scores they get in here. So that's how you use dictionaries, by a key and a value. That's all from me today, and now I'm going to pass this on to Danielle. Thanks for listening.
So I'm going to be doing file input and output. So this is only just a quick little section. So we started off with open, and then the file name with the, so it's I, the colon, file, and then the txt as inputted as a string. Then here we get to define what we're going to do with it. So right now we're going to read. Read is already like the default, so you don't have to put it in, but we will be using wsin. So right now we're going to use R. And then as this is the name of the file. So right now we're just going to call it the file. Then just print it out as whatever we called it. So file dot read. Yeah, there you go. So it is space sensitive. So you have to get the spacings right, but all of this is within a string. So we can also write to it. Writing to it completely wipes out everything else that's within the text. So what's more interesting is appending with an A. And then we get to define what we want to write to it. So we're just going to say, and we're going to put all of this within a string. And then we can also add another one. We use this file.writeLines function. And we're going to input the lines we just wrote. And then should file.read again. So we can also write multiple slides onto it. We can also add loops, which we should be seeing soon. They're introduced with lambda functions. So I'll pass it on to Steve.
Hey everyone, yeah, I am Steve. I'll be covering the next topic, which is plotting graphs. Now, plotting graphs is really useful because it allows more visibility into whatever that it is you're developing, especially in like a competition style setting. And to do this, we use a library called matplotlib, which allows more visibility into plotting your data from files and like maybe functions. And to install, this is one way of installing it. There is a pip command on your terminal that you can use, pip install matplotlib. And you must run this line because it doesn't actually come with Python by default. So Okay, let me start my demonstration. So to actually start using matplotlib, you need to import it first. So import matplotlib. And the usual way of doing this is we actually want the pyplot module in this package and import it as PLT. And what this does is essentially, it's just a shorthand for using this long name. We don't have to refer to this long name, just call it PLT. And for matplotlib to work, we need to provide some points on the 2D plane for it to actually plot something. And the way this is done is that we first provide a collection of values on the x-axis, and then provide the corresponding y coordinates for each x value. So for example, let's say we wanted to plot a formula, such as, I don't know, y equals log x. Let's define that formula as a function called f. It will take in a number, x, and it will return log x. And if you actually want to use some of these mathematical functions, there is another library called math. It's already built into Python. You can just import it and you'll get access to like a lot of these interesting functions. Now, as I said before, we need to prepare some x values. So if we wanted to plot this formula for like different values of x, we need to supply it in a list. So let's say we want to plot it for 1, 2, 3, 4, 5. That'll be the x-axis. And we need to map each value now to the function. So for the x value of 1, we want to plot f of 1, and so on. So we defined a function that we wanted to plot. There's a log function. We had values for the x-axis. Now we want y values for each of these x values. And there's a really neat way of doing that. It's called list comprehension. And you basically run f of x for x in x-axis. It reads very nicely. So it's like it will apply f to each of these values in the x-axis. So f of 1, f of 2, f of 3, f of 4, and so on. And so now that we have these axes ready to actually plot it, we just use the plot function. And we just given the x-axis and the y-axis, just like that. And finally, you need to call the show function to actually display this. So basically, you can think of it as the plot being like preparing a plot, and show is like actually displaying. Let me run this. Yeah, and you can sort of see here, let me make it more visible. Yeah, so what matplotlib has gone and done is that it will kind of match up like the x and y values together. And if you see like these little corners here, those are like exactly the points that we drew. And by default, matplotlib will connect these points with a line. So yeah, that's a really basic plot. But now, I guess, you know, a formula is nice and all, but there are more useful things you can do. So for example, maybe this might be really useful in this competition. You can read data from a file and plot that data as a graph as well. So here I've prepared some sample stock prices for Tesla. We're gonna try read it in. And if it wasn't clear from the previous section, we use the with command. So with keyword, open the file name, so stock prices, and to start reading, you do R. And you give it a name. So you give this file a name, we call it F. And what we can do now, the prices, it's going to be given in like one price per line. We just read all the lines. So f.read lines. This will give us a list of all the prices. But we still have to do a bit more of this. This is more involved. These are actually strings. We want actual numbers. So we need to convert each line into a number. And we can use that list comprehension thing we saw before. For each line in this, like the list of lines, we want to convert it into a float, so like a decimal value. But before we actually do that for the line, we want to get rid of any characters that aren't numbers, and that's called strip. So this will actually get rid of like the new line character at the end of each line. Yeah, so we want to convert each line, strip it of all its unnecessary stuff, turn it into a float for every line in the lines. So as I mentioned before, you need an x-axis as well. These prices would form the y-axis. So the x-axis it would probably be just like the numbers from 0 to all the way however many prices we have. So the way we can do that, if you remember the range function, the range function gives us all numbers from 0 up to a certain point. So if we do range of the length, that's the len function of the prices, that gives us numbers from 0 to all the way up to the number of prices. We want a list of that, and there's again a function we use, which is list. Again, if we use the plot function to do this, x-axis and the y-axis as prices, we'll be able to see the stock prices. Let's have a look. Yeah, there you go. Looks pretty legit. It looks like a stock to me. Yeah, and there we have it. That's how you plot data from a file. Now, I guess, we know what we're talking about. We know this is a stock price, but probably we would like to let other people know what this is about. And this graph is a little bit incomplete in that sense. It'll be better if we can have some sort of labels in this graph. So something like a title, or what do these x and y axes mean? And we can do that really easily. So for a title, the function is just called title. It's a price. And what you pass in is a string that is the title. So you can go Tesla stock price. Yeah, if you wanted a label for the axes, the x-axis has this function called xLabel. And again, you just pass in the name of the x-axis. We can just call it time. And for the y-axis, it's the same. So y-label, you can call it price in, I don't know, dollars. And if we print this, or not print, show this, you'll see the title and the axes levels. Yep, so you see the title, price, time. So that looks a bit better. Now, at the moment, it seems like we can only plot one thing at a time. Once we use the show function, we only get one plot. And in reality, you might want to actually, compare two things, for example. You might have two stocks that you want to compare the price. And you can actually do that. Matplotlib has you covered. So I'm going to read in another file with the same with keyword, more stock prices, read it, which is R, I'm going to call it F again. And we're just going to get more prices. We're just going to replace this prices list with whatever prices are in this one. And do the same thing. So x-axis is still the same. We can use the same one. Same command. And just plot it again. So notice that we use the plot function twice before this show. So that's what I meant by preparing a plot. We prepare two plots before actually displaying the whole thing. I'll get rid of these labels. Let's run that. Hopefully that works. And yeah, there we go. We have two stock prices. Now, for someone who doesn't know what we're talking about, they might be confused, which stock is this talking about? Well, again, we can add something like a legend to this graph. Also, if you didn't like the colors that got default set to us, we can actually customize that as well. So we can make the first Tesla stock maybe green using this syntax here. So you do color with the American spelling equals the string color that you want. Let's make the other one red. And for a legend, it's just simply plt.legend. And you supply a list where you have to give it in the order of the plots that you did. And it's a name for each. So we can do the first one as Tesla. And the second one, I don't actually know which company it is. Let's just call it Google. Yeah. And once we do that, we should get a legend somewhere in the corner. Yeah, So now we can distinguish between these two different plots if we're trying to plot something like multiple things on the same set of axes. Okay, right, so this is only for plotting many things on the same set of axes. And sometimes we might actually want to plot these separately, but at the same time. So like side by side. And we can also do that again. And that's via the plt.subplots subplot function. And for this, we need to supply how many rows of graphs we want and also the columns. So if we want to plot these two stocks side by side, that's one row with two columns. And we just do it like this. And what is returned is something called a figure and a bunch of axes. And axes is like the separate plots that we can work around with. And this is how you would, it's like usually this will be the pattern where you actually retrieve the individual axes. And you can treat these as like the PLT that we used before. So instead of PLT.plot, the first one can be drawn on the first axis, and the second one could be drawn on the second axis. And I'll get rid of the legend now. We don't really need that. We can also have like a title for the overall plots. And that's where the fig comes in. Fig is like a representation of like all the axes combined. So if you want to title like on the top of the page, you can use fig.subtitle. So fig.subtitle. I think the sub stands for like superior stock prices. And if you wanted to, you can have individual titles as well using the AX axes. So AX1, you want to set a title on the first one? Well, you just use set title. That could be Tesla. For the second one, you can do a similar thing. Yeah, and let's do that. It works. I see. Okay, so we have some error here. Let's just read what it says. Subplot takes one of three positional arguments. So what this means is that this function, it expects to get 3 parameters, or 1, and not 2. So let me try something like this. Okay, it just seems like I spelled the function wrong. And we should get 2 plots like this. Yeah. Okay. Yeah, that's how you draw graphs side by side. Now, you might be getting bored with line graphs so far, but Matplotlib also has functionality for other kinds of graphs. I won't go into the details of those. There's stuff like histograms, scatter plots. You can always find them in the Matplotlib documentation, or just like online tutorials and examples. Okay, so let me go back. That concludes the Matplotlib section. Now when we're moving to Numpy. So Numpy is another module, just like Matplotlib. It provides a lot of useful tools. So basically, this library, it helps you work efficiently with lists. So you've seen lists before, but the problem with actually working with lists is that they can get really slow when you get really, really large lists. And you might be dealing with like huge data sets when you're working in this competition. So Numpy is a way of efficiently doing it. It provides that efficiently. So let's have a look about how it works. Before that, the installation is just similar to the Matplotlib. We use the pip install. Let's move on to the demo. So to use Numpy, we're going to use a similar shorthand as before. So import Numpy. And the usual convention that you'll see is doing NP. So NP is just going to be another name for NumPy. Now, if you want to actually create a NumPy array, the easiest way of thinking about it is that they're literally the same as a normal list. If you wanted an array A, you want to like call the array function, and you pass in a list that you want represented as the array. So let's have like a 2-dimensional one, which is a list containing lists. like a grid of numbers like that. 7, 8, 9. Let's go ahead and print it. It's going to look like what you expect. Let me close this out. Yeah, so it's going to print like a regular list. If you wanted to access elements, it's really similar as well. If you remember the how we index arrays or lists, they start from 0. So let's say if we wanted to increase this middle element by 1, or like by 10, you have to go to the first row, like because we start at 0, the first, like the 1th row is like row 2, and within that we use index 1 because that's the second element in that row. The way we access that is we supply like row column. So row 1, column 1. If we want to increase it by 10, we can use this operator. And let's print out A again. Get rid of that. Yep, so yeah, we have gone ahead and added 10 to this middle element. Yeah, so these are just like the really, really basics. There's a lot of useful operations that Numpy provides for these arrays. So it really saves us time from implementing those operations from scratch. So let's say we have like this 2D array. And if we were using lists instead, to find like the total sum of the numbers, we would have to do something like for like each row in the array, for each number in the row, add this to the sum, like something like this. We'll need like a lot of loops. But for NumPy arrays, we get added functionality, and it just straight up goes to this function here, the sum function. If you call it on an array, it will just, I guess, magically sum up everything for you and return the result. So let's actually print the sum here. Yeah, it's 45. You can check that, add 1 to 9. But yeah, it's really as simple as this. This isn't the only operation. There's like a lot of like similar ones. There's like stuff like average, or there's also things from linear algebra where we treat these 2D arrays as matrices, and we can do something like matrix inverse or matrix multiplication. You can figure that out online. There are many resources for this. So let's do a simple exercise, trying to like make sure we understand like that we can use these shorthand functions. So let's say we have an array of random numbers. We have a big 2D array of random numbers. I'm going to generate it using the NumPy random module. And this allows, this is just an aside, but this basically allows you to make a normally distributed table of numbers. And you can specify how big the size is. For the normal operation, the normal distribution, if you know statistics, you need to provide a sort of like the middle point, average. That's called 50. The standard deviation, that's called 15. And the size, well, we want it to be 20 by 20. I'll just print that out just to convince you guys. If you do that, you'll get, yeah, we got tons of numbers here. So the exercise now is to kind of find the range of numbers in this 2D array. So what that means is we need to find the minimum and maximum numbers of this array. And with a usual list, you would have to go through every single number, check what's the smallest, or like check what's the biggest. But with NumPy, you can simply do the min and max function. So the minimum, we just simply call a.min, and maximum, a.max. And we can print the range of values is, let's make this an F string, is minimum to maximum. Let's go ahead and print that. And it turns out that these two numbers are like the range of values in the array. So it's like very simple. You didn't need to use any loops. Okay, so now let's move on to a really important topic in NumPy. And it's called the axis parameter for like a lot of functions. So for this, I'm just going to demonstrate an exercise first and see how I can motivate this example. So let's say that consider that we're running a store, and that like on each day we recorded the number of shoes sold by size, and each day is going to be represented as a row in a 2D array, and each number in this row tells us how many of each shoe size we sold on that day. So if we have like a row like I don't know, 4, 5, 6, 7, that could mean that like one of the sizes we sold 4 of them, another size we sold 5, and this will represent a day. And we have a lot of these rows representing different days. I have this as a file in sales.txt. So I'm going to open it. So with open sales.txt, we want to read it as F. We want to get all the, I guess, rows and columns. And NumPy has a function for that. It's called NumPy np.load.txt. We don't actually need this anymore. If we supply the actual file name, it will automatically read it for us and convert it into a 2D array. So, and this returns it. So we can just say A, well, sales is the, we just load the text. I'll just show you what the file looks like. It's just a bunch of numbers. So the first day is saying each of these sizes, we sold however many, and we have many days. Now, our goal is to figure out for each day, the total number of sales, and also for each size, the total number of sales. Now you might be wondering, like, isn't this just the sum function as before? Well, it is, but like, we don't want the sum of the entire numbers because that'll just be saying sum up all the sales, like no matter what size, no matter what day, just sum up everything. And we don't want that. We want to sum for each day. So like, sort of like each row. And for each size, we want to sum for each column. And that's where this axis parameter comes in. We can use the same function, but most of these functions, they have this parameter axis that we can specify. If we do an axis of 1, that means we're summing across rows. And an axis of 0, actually no, I got that the wrong way around. Axis of 1 means that we are summing across a row, and axis of 0 means we're summing across the columns. So if we wanted the row sums, which is the sales per day, that'll just be this over here. We're gonna sum up the rows and the sizes. So we can, let's give this a name. So per day, sales by day. And the column sums will be sales by size. It's the same thing, just axis is 0. And if we print these out, so print sales by size, so run that. We're going to get more NumPy arrays, but now the first one here, it's like sort of collected the sums for every row. So on the first day, we sold 302 shoes. On like the 6th day, we sold 280 and so on. And the other one that got returned, that's the sales by size. So for the first shoe size, we sold 318 of them and so on. This axis thing, there is a more formal definition of this for like higher dimensional arrays. You might have like a cube of numbers instead, and that gets a bit complicated. You can read online tutorials for that. Okay. So for NumPy, there are actually way more operations than this. You can do operations between arrays, so like binary operations involving 2 arrays together. For example, if we have, let's get back that array. Let's just say like the same one we had, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we wanted to like kind of multiply everything in this array by some factor, like kind of scale it up, it's just as simple as this. So 8 times 2. What that will do will double every element in the array. Let's print 8 times 2. And we should get back. Yeah, so all the even numbers. So 2, 4, 6, 8, blah, blah, blah. We can also add 2 arrays. So if we had like another array, and actually, these arrays that you add, you don't actually have to be the same size. So if you say like, I don't know, if you wanted to add a row, which is just a single list, I don't know, 10, 10, 10, to this array, you can specify like which row you want to add it in. So if you wanted to put it in the last row, you could do something like a plus equals, or not a, the second row of a plus equals b. And what that will do, it will add 10 to the bottom row. I did not print. Let's actually see it. Yeah, so the v was added to the last row there. All these arithmetic operations, they're done element-wise. So if we did like a times equals instead, then each, the first one in the last row, that will be multiplied by 10, and second one multiplied by 10, third one multiplied by 10. Might be better to just make new arrays. Let's say A is, let's say 1, 2, 3, and B is MP dot array 4, 5, 6. Then A times B is like for each pair element-wise in these I guess vectors or arrays, whatever you like to call them, it will multiply them together and give you another array of the same size. So the first one would be 1 times 4, second one 2 times 5, third one 3 times 6. Okay. Just for the interest of time, let's move on. So there is another useful thing that we can do with arrays. When we're using the square bracket here, we either supply indices or we can supply a range of indices. So if we actually wanted like, I don't know, like the top right corner elements here, we can actually do that by saying, okay, we have A, we want the rows 1, rows 0 to 1. So we want the first 2 rows. We do that with up to 2. So this column 2 is saying the first 2 rows. And for each of the 2 rows, we want column 1 and beyond, which is 1 column. And if we do that, we'll get like a square grid, like square like sub-array of this A array. Yeah, so we get the top right corner. So this is like sort of giving us a view of the array. Now, sometimes you might actually, want some values that aren't actually in a range. So they might be like all over the place. And how do you do that? You want to like, maybe you want to select values that satisfy a certain condition. Well, let me show you through this exercise. So the scenario is we have a forest and we're given it as like a grid of trees and we record the heights of each tree. So let me show you. So we have this like massive forest, each number represents the height of a tree. Now we've realized that the tallest trees, we actually made a mistake in recording their height. Their height is actually supposed to be twice as what was recorded. And our job is to sort of fix that mistake by multiplying all those tallest trees by 2. Let me read that first. So with open forest, we want to read as F. We want to make a numpy array of all of those. Actually, we don't need that again. We just do np.load text with the file that we want, and we get like a numpy array representing that data. Now, we want to find all the trees that have the maximum height. And the way we do that is we do something where we supply a condition inside these square brackets. So we want a maximum. And the way we do that is we want to only pick the values in A where the value is the maximum of A. And if you actually print this, it might be a bit confusing. Let me explain what is going on. So this actually went ahead and found all the trees, all the types of the trees that have the maximum value. Another thing you can just like see for yourself. A.max. If you just do the condition like this, you'll get another array back with the same size, but wait, if this loads. Yeah, so you'll get like a bunch of true false values. And what it's saying is that it sort of replaces that array by like the answer of this question. So like, is that value actually the maximum in the array? If it is, then it will like replace it with true, otherwise false. And if we want to double everything that was the maximum height, then we simply do that thing. We want to select all the values that are equal to the maximum, and we want to double them because that was our mistake. And if we print A, we should get a bunch of 18s. Yeah, so we see all the 9s have been turned into 18s, and that fixes our mistake. Okay, so that's it for NumPy for the time we have. We'll be moving on to the Pandas topic. Over to you, Daniel.
So we'll be using Pandas. Pandas is mainly used for data frames. That's its best use. We can also read files just for quick access using Pandas. And right now I'm gonna make a demo of actually making a data frame using Pandas and then manipulating it. Import Pandas, just like we did with NumPy. And we're gonna everyone usually calls it PD. Call our data frame data, and we're gonna make it almost like a dictionary. I'll just quickly do 1, 2, 3. I just put commas within here. Comes up. So we should convert it into a data frame. Yep, there you go. So now we get it actually as a proper table. So now I'm gonna see what we can do to like try to manipulate it and try to get inputs out of the data frame. So we're gonna try to get just the math scores. So we're gonna explore this math scores. And just like the list, we're gonna get the math one, but we're gonna put it in again as a string. So now that we have our math scores, we're gonna try to get the highest score. Just like we did before, but now since we called it math scores, we can actually just use that one. I'm gonna say greater than 2. Yeah, so there you go. So now we can also use out of other functions. The other functions do have to be included as the group by function in whatever category you're in, and then we can actually get the mean using that. So I'll try that again. Yeah, group by. This is always going to be one of the columns, so math. And we try to get the mean from that. And then you can use mean. There's other ones that you can search up on the document forum.
Thank you, Danielle. So packages. So packages are essentially a collection of modules that are related to each other. And one of the packages are called iteratools, which is a package that provides a range of functions that help with data manipulation and efficient looping. For example, I'll be going through the product and permutation functions. So firstly, we need to import the product function. We then define a list of numbers called list1. We then define a list of characters or list2. And finally, we write a print statement that uses the product function with list1 and list2 as arguments to obtain the Cartesian product of list1 and list2. Yep, and that should work. And now I'll be going through the permutation function, which refers to all the possible combinations in which a set or string can be ordered. So firstly, we import the permutation function. We then define a list of characters called list1. We then apply the permutation function with list1 as the argument, which contains a string of characters, and assign it to list2. And finally, we print out the content within list2. And as you can see, these should be all the combinations that can be formed from list1. Now moving on to the next package called sklearn, which is used to analyze data to help users make informed decisions. For example, using classification and sorting data based on patterns. Or we can create a regression model, which can be used in trading to predict stock prices and movements based on historical data. And finally, PyTorch, which provides a set of tools for building and training neural network models. For example, these models can be used for tasks such as price prediction, identifying trends, and portfolio optimization.
All right, thank you, Chris. That concludes this Python workshop. Thanks everyone for coming. These slides and the recording will be released on Facebook. Thank you for coming.